Welcome to the MSBTE online learning platform. We bring you the most relevant content in an exciting digital format. Today we will be studying a very interesting module from Applied Mathematics Integral Calculus, which includes topic Methods of Integration Part 2, where we will be studying some interesting facts about Methods of Integration Part 2, and we will be practicing some of the examples based on it. So let's begin. Module is Calculus, topic is Methods of Integration Part 1. Integration is a way of adding slices to find the whole. Second objective is integration can be used to find the areas, volumes, central points, and many useful things. Third objective is evaluate integral using the formula of integration by substitution method. In this lesson, student will be introduced with different types of substitution, while substitution helps us recognize derivatives produced by the chain rule. Integration by substitution method. In some integration of f of x dx, directly evaluation is difficult or not possible. So in such integrals, transform integrand into the another form by changing independent variables x to t by substituting x is equal to g of t. What is our integration? I is equal to integration of f of x dx. What substitution I have taken? X is equal to g of t. After substitution, we will differentiate the substituting value with respect to x. So differentiating with respect to x on both the side. So what is the derivative of x with respect to x? It is 1. And derivative of g of t with respect to x is g dash t into dt by dx. So these are the main two steps. So now what is our integral? I is equal to, this is our given integral. We are converting this given integral in terms of t. So what is the conversion for this? I is equal to integration of f of x, but for x I have taken x is equal to g of t. So in place of x we will write g of t. Then substitute the value of dx. Dx is what? G dash t into dt plus constant of integration, because this is a indefinite integration. Now there are many types for the substitution. Integration by substitution. So we will discuss some of that types. First we will discuss integration for trigonometric function. Then integration for logarithmic and integration for inverse trigonometric function. Now integration for logarithmic function. I explained that with one simple example. In integration, there is a log. If there is a log term, then use the substitution for log. What does that mean? If the integration, if you see any log function, any log term, then use that full log term for the substitution. For example, suppose we have to evaluate integration of cosec x sec x dx upon log tan x. First we'll substitute, let I is equal to integration of that term cosec x sec x upon log tan x into dx. Now in this problem, what is a log term is given? It is log tan x is given. And what is that given? If any log term is given, use that term for the substitution. So we will take here substitution for log tan x. So we will take log tan x, t is equal to log tan x. This is the first step. We have taken the substitution t is equal to log tan x. What is the second step for that after substitution? We will differentiate that with respect to x. So what is the derivative of t? It is dt by dx. And what is it is given? Log tan x. How we find the derivative of log tan x? Log tan x is a composite function. So definitely you have to take derivative of log as well as derivative of tan x, because log tan x now a composite function of the log and tan x. So derivative of t with respect to x is dt by dx. And log tan x derivative is, first we'll take derivative of log, that is 1 upon tan x, into derivative of tan x, that is sec a square x. Now, after that we will convert this tan x into sine and cos form. Why I am converting that I will explain later on. But first we will convert this tan and sec x into sine and cos form. So 1 upon tan x is what? Sine x by cos x, and sec square x by 1 upon cos square x. Now you will easily see that this one cos x from here and this cos x get cancelled. So now what is the our right hand side? Left hand side will be same, dt by dx. But what is the right hand side? Right hand side is 1 upon sine x into 1 upon cos x. And we know 1 upon sine x is cosec x and 1 upon cos x is sec x. Now what is the value of dt from this? What is the value of dt from this? Take dx to that side. Take all the x term to that side. So what is dt? Cosec x into sec x into dx. We will take dx to right hand side. We will collect all the x term on the one side and all the t terms or constant term at the one side. So value of dt is cosec x into sec x into dx. Now why I am doing this? Cosec x into sec x into dx. This is our question. I is equal to integration of cosec x into sec x into divided by log tan x with respect to x, that is dx. And we are already used a substitution for log tan x. So in this integration, our log tan x is t. So what about the numerator? Numerator now we got in terms of dt. So our numerator is now cosec x into sec x into dx. This is the main thing about the substitution method. After substituting, whatever the derivative term you will get, that derivative term will be in the given integral. So here in the integral, this derivative is given. Cosec x into sec x into dx. So you have to think about what substitution you are using and its derivative is given there or not. If it is given there, that means you have to use a substitution method. If it is not given there, that means you have to follow some other method. I is equal to integration of, now this full numerator is our dt, denominator that is log tan x, for that we have used a substitution t. So integration is reduces to integration of dt by t. Now first that is in terms of x. Now we will reduce that in terms of t using some substitution. And what is the in for the substitution? Derivatives term should to be given there. And we know the integration of 1 upon t. What is the integration of 1 upon x? It is log x. So in the same way you have to do the integration of 1 upon t. Integration of 1 upon t is Yes, it is correct. It is log t plus c. And after that, you have to resubstitute value of t. And what is t we have taken? That is that log tan x. So in place of t, we will write I is equal to, resubstitute the value of t. And therefore, what is our I? I is equal to log. And what is t we have taken? Log tan x plus c. That is our final answer. Log of log tan x plus c. Now we will go for the next method, that is trigonometric method. This trigonometric method I have divided into two parts if the angle is given x and if the angle is given other than x. If the angle is other than x, then use the angle for substitution. For example, evaluate integration of e raised to x, x plus 1 upon cos square in the bracket e raised to x into x dx. Now what is a trigonometric function is given here? It is cos square. So definitely this will be the angle for this cos. And what is given? If the angle is other than x, use that angle for substitution. So here we will use angle e raised to x into x for substitution. So what is this? We will take, this is our given integration and we are taking substitution. E raised to x into x is equal to t because here angle is e raised to x into x. So this is e raised to x is first term and derivative of x is 1 plus e raised to x into derivative of second term into first term. This is first term, this is second term. First term as it is, derivative of x is 1 plus second term as it is, derivative of e raised to x is e raised to x equal to derivative of t, that is dt by dx. Now what is the next step? We are taking e raised to x common. So when we take e raised to x common, what will be in the bracket? E raised to x we have taken common. So from this is 1 and from this is x. This is x plus 1 is equal to dt by dx. What is the next step? We will take all the term with all the x term with dx and we will take dt at one side. So next step is what? E raised to x in the bracket x plus 1 dx equal to dt. Now why we are doing all this thing? Just look at our integral problem. What is given? Integration of e raised to x, x plus 1. That term we want in terms of dt here. So now we get that e raised to x, x plus 1 dx. So our full numerator is now dt and for denominator we have taken the substitution. So this is what? Cos square t. So what will our integral? I is equal to integration of this full term, that is our numerator is dt. So this is dt upon cos square in the bracket e raised to x into x. Now substitute this in that equation. So our integral reduces to integration of dt upon cos square t. Just compare these two one. This is from the dt we get that values and our denominator is now cos square. For e raised to x into x we have taken the substitution, that is t. So this is dt upon cos square t. Now tell me how we will find integration of dt upon cos square t. Do you have any idea how to find it? Yes, we will convert that 1 upon cos square into the sec square form. So 1 upon cos square is sec square t into dt and we have directly formula for integration of the sec square. So integration of sec square is, it is tan t plus constant of integration. Now we got a value. After this, what is the last step? Resubstitute the value of t. And what t we have taken? It is e raised to x into x plus c. This is the final answer. Now we will go for the second example for the trigonometry. Integration of cos x upon sin square x plus 1. So let sin x is equal to t. Is it clear why we are taking sin x not cos x? And why we are taking the full trigonometric function? Because angle is x is given. Angle is not other than x. And the methods are same. The steps are same. After this we will take derivative on both the side. So derivative of sin x and derivative of t. And what is the derivative of sin x? It is cos x. And derivative of t is dt by dx. Now tell me what will be the first step? Next step we will take dx to next side. So what is our value of dt? It is cos x into dx is equal to dt. Now check our integration. This is a given integral. And what we got? Cos x into dx, that is nothing but our dt. That means this term is now reduces. So in this way you have to think what substitution we will take if the angle is not x, or if we are taking the substitution, is the derivative is present in the integral or not. So in this way you can use the substitution method. If the derivative term is not given, so definitely we have to follow some other method. Now what is integration now? Integration of dt upon t square plus 1. Because that term cos x into dx is now our dt upon t square plus 1. And what is the integration of 1 upon x square plus 1? It is tan inverse x. Now in place of x here it is t. We are integrating with respect to t. So we will use that formula, same formula, but we will write down t there. Integration of 1 upon x square plus 1 with respect to x is tan inverse x plus c. So integration of 1 upon t square plus 1 with respect to dt will be tan inverse t plus c. Now resubstitute the value of t. And what t we have taken? We have taken the t is sin x. So what is our I? I is equal to tan inverse sin x plus c. And that is our final answer. Now tell me, is it clear to all of you in the integration if the angle is given x or if the angle is given other than x? I hope that it is clear to you. That is inverse substitution. Using inverse function for substitution. For example, evaluate integration of tan inverse x the whole cube upon 1 plus x square with respect to x dx. Now, first we consider the given integration is I is equal to tan inverse x the whole cube upon 1 plus x square. What I have told for the substitution, if we use a substitution, that derivative term should to be there. In the inverse function, we will use the inverse term as a substitution. So what is the inverse function given here? It is tan inverse x. And what is the derivative of tan inverse x? It is 1 upon 1 plus x square. Is it given there? Yes, it is given there. 1 upon 1 plus x square is given there. So that means we can use substitution method over here because we are using the substitution for tan inverse and its derivative is given over here. So these are the hint. If the derivative term is given there, use the substitution method. So if it is inverse function is given, use the inverse function for the substitution. So here inverse term is what? Tan inverse x. So we will use t is equal to tan inverse x. And what is the next step? That is a common method steps. Take the derivative on both the side. Derivative of tan inverse x is 1 upon 1 plus x square. And now I think it is clear. What is the derivative of t with respect to x? It is dt by dx. What is the next? We will take dx with x term. So dx will go that side. This dx we will take that side. So we'll get a value of dt in terms of x term. So dx upon 1 plus x square is now dt. And what is integration? I is equal to integration of tan inverse x the whole square upon 1 plus x square. For numerator tan inverse x, we have used a substitution. What is that? That is t. So that will be t cube. And what about the rest of the term? Dx upon 1 plus x square. Check our dt value. This is dx upon 1 plus x square. That means that dx upon the remaining terms are nothing but your dt. That will happen in every substitution type. The term which are you substituting, except that all the value come as a dt. So this is integration of t raised to 3 into dt, because this is t cube and this term will be now dt. So integration of t cube into dt. That means that term is reduces to now this value. Integration t cube dt. Now I will find the integration of t cube dt. The integration of t raised to 3 is t raised to 4 by 4 plus c. It's the same way. Now what is the last step? Resubstitute value of t. What is t we have taken? Tan inverse x. So what is I now? Tan inverse x, the whole raised to 4 upon 4 plus c. I think this will you find out now simple. If it is an inverse term is given, use the inverse function for the substitution. Definitely you will get an answer very soon for that. So this is our final answer. I is equal to tan inverse x, the whole raised to 4 upon 4 plus c. Now we will go for integrals of the form integration of a sin x dx upon a sin x plus b, integration of dx upon a cos x plus b, integration of dx upon a sin x plus b cos x plus c. There are some steps to solve the above kind of the integration. Substitute t is equal to tan x by 2. Look, these are the fixed value for this type of the integration. You have to take this fixed value for that type. T is equal to tan x by 2, sin x is equal to 2t by 1 plus t square, cos x value will be 1 minus t square upon 1 plus t square. Even the value of dx is also given. What is dx is, we will take the value 2 dt upon 1 plus t square. Look, this is a one particular type of the integration. In this directly you have to use these value for sin, cos, for dx and for dt also. If the type is integration of dx upon a sin x plus b, a cos x plus b, a sin x plus b cos x plus c. For this type, you have to use these value. Why we are taking sin x is 2t by 1 plus t square? Because there is a formula for sin x in terms of tan. That is 2 tan x by 2 upon 1 plus tan square x by 2. And what is tan x by 2 we have taken here? We have taken tan x by 2 is t. And that value we are substituting for sin and cos. And what is cos x in terms of tan x? 1 minus tan square x by 2 upon 1 plus tan square x by 2. So these are the directly values is given to solve that type of the integration. You have to just remember these values. Value of t, value of sin x, value of cos x and value of dx for the above type. Now substitute above values. These are the steps I am explaining to you. Substitute above values in the given integration, simplify it and solve the integration. This is the second step. For example, suppose you have to evaluate integration of dx upon 5 plus 4 cos x. This is of the type, yes, integration of dx upon a plus b cos x. We are in place of a, here it is 5. In place of b, here it is 4. And all the values are given to you. We know the value of dx, we know the value of cos x, we know the value of t. So t is what? It is tan x by, directly we will solve this by using that values. So consider I is equal to integration of dx upon 5 plus 4 cos x. And we will directly use this value. T is equal to tan of x by 2, cos x is 1 minus t square by 1 plus t square and dx is 2 dt upon 1 plus t square. So now we will reduce that integration. I is equal to integration of, in the numerator there is dx. And what is the value of dx here? Yes, it is 2 dt upon 1 plus t square. And then denominator, what was the denominator there? 5 plus 4 cos x, and value of cos x is what? 1 minus t square upon 1 plus t square. Now there is a fraction. Outside the fraction there is a number and we have to simplify it. We can't directly cancel out this 1 plus t square, 1 plus t square. We can't do that because this is a composite. If that comes with plus and minus sign, first you have to make the denominator same over there. Then only you can cancel out this 1 plus t square. This is the step in which most probably students did the mistake. What they do directly? They directly cancel out this 1 plus t square, 1 plus t square. They do not think about this 5. Look, 5 is come as a first term and this is come as a second term. So first you have to simplify this bracket and then you have to perform cross multiplication and then only you can cancel out this 1 plus t square and 1 plus t square. Hope so you understand what I want to say to you. You can't directly cancel out that 1 plus t square. So what is that now? Numerator will be same because we are not doing anything with that. So in numerator is 2 dt upon 1 plus t square. And here first we perform the cross multiplication. Take 1 plus t square with 5. So what is the simplification? 5 will come with 1 plus t square. This is plus 4. This is plus 4. And this will 1 minus t square. Now this full term divided by 1 plus t square. In this way, first you have to make denominator same. So now we can cancel out 1 plus t square, 1 plus t square cancel out because this is the denominator for the numerator and this is the denominator for the denominator. Now we can cancel out, but here we cannot cancel out because we have to first multiply this 5 with 1 plus t square. Is it clear? Do you have to remember that step? You can't cancel out that 1 plus t square directly. Now definitely you have to open the bracket, you have to simplify it. Multiply the first bracket with 5, second bracket with 4. So 5 into 1 is 5, 5 plus t square is 5t square, this is a plus sign. 4 into 1 is 4 and this is minus sign, plus into minus is minus, this is 4t square. So now t square you have to collect at one side and 5 plus 4 that is a constant. So what is the denominator simplification? I is equal to integration of 2 dt upon t square plus 9. So now 2 is a constant and what is the first rule of the integration? Take the constant term outside the sign of the integration. So 2 is a constant, so we'll take 2 outside and this is dt upon t square plus 3 square. Why I am writing the 3 square over there? Yes, we have to apply the formula. Which formula? Yes, integration of dx upon x square plus a square. What is that formula? Yes, it is 1 upon a tan inverse x upon a. But in place of x, here it is t because we are using substitution method. So x is 1 upon, this is 1 upon a. In place of a, it is 3 tan inverse x upon a. What is the formula? This 2 will come as it is. For this, you have to apply the formula. 1 upon a, in place of a, here it is 3. So 1 upon 3 tan inverse x upon a, but in place of x, here it is t. So this is x upon 3 plus c. Now this is 2 into 1 by 3. What is 2 into 1 by 3? Yes, it is 2 by 3. 2 by 3 and then resubstitute the value of t. What t we have taken? It is tan x by 2 divided by 3 plus c. Now in this I want to explain one thing. You can't multiply that 2 with that 3 because that tan x by 2 means their angle is x by 2 and that we are writing with it the tan inverse. For which the angle is what, term value is what? That tan x by 2 divided by 3. So these two, that 2 are two different things. We cannot multiply that 3 with 2. So this is clear to all of you. Here the students can make the mistake. They directly multiply that 2 with 3. But this will not happen. These two are totally different terms. They are treating very differently from each other. And then write down constant of integration, that is plus c. This is the final answer. This is 1 upon 3 tan inverse tan x by 2 upon 3 plus c. First, tips and trick is, in the integral, if there is any logarithmic function, take log term for the substitution. If in the integral any log term is given, use that log term for the substitution value. Second is, in the integral, if there is any trigonometric function with angle x, then use that one of the trigonometric function for the substitution. And if angle is composite term or in terms of x, then use angle for substitution. After substituting, take the derivatives on both the sides. Take all the x term with dx and one side and dt with constant at the other side. You have to find out value of dt in terms of x and dx term. Then substitute the given integration, substitute into the given integration and reduce the integral in terms of t. Solve the given integration by applying standard formulas. Point 8 is resubstitute the value of t. Yes, students, do you have any questions?
Yes, I have. How to identify which type of substitution we have to apply for what type of integrals?
Okay, your question is very good because this is a question that I expect from my students. Look, I have explained all the types of substitution. If there is a log term, then apply the log term for the substitution. If there is a sign with some angles, then angle for the substitution. If there is not an angle, x is there, then any one of the trigonometric function will come as a substitution. And if it is inverse term, then inverse function will come as a substitution. And if the type is given that dx upon a sin x plus b, a cos x plus b, then the substitution values are fixed. In this way, if you have learned all these values, all this concept clear to you, then able to find out which type of substitution you have to use for that given integrals. I hope that it's clear to all of you.
Yes, ma'am. Thank you.
First is integration is a way of adding slices to find out the value. Second is integration can be used to find areas, volumes, center points and many useful things. And the third one is evaluate integrals using the formula of integration by substitution. And we have seen many substitution methods. Just you have to recall that and you have to remember that step and what substitution for what term you have to use. Just you have to use that. Then it will be very easy to find out, to evaluate the integrals. In this topic, we learn how to fit the integrals pattern in different frames of substitution. How to solve the problems on a particular type, taking the fixed values of sin x, cos x and dx. That values is given on that problem. Now, you are fully competent to solve the problem of integration by substitution method. So, worksheet is given below. Try to solve it. The solution of the worksheet is provided for cross verification. What is the first question? Evaluate integration of cos log x upon x dx. I am just giving the one hint. Log term is given. Use a substitution for the log. Now check out your answer whether you got the same answer or not. Answer for this question will be sin of log x plus c. Have you got that? Just check out. We take the derivative, we find out the value of dt, substitute the values and answer is what? Sin of log x plus c. At the end you have to resubstitute the value of t. Second question I have given this. Integration of 2 raised to tan x upon cos square x dx. Here student make a mistake of what substitution they have to use because cos is given. And if you use the derivative of tan, it is sec a square x. But you should to know that there is a relation between the sec a square x and the tan 1 upon cos square x. We know 1 upon cos square x is sec a square x. So that in that way you have to think about. And either student can get confused because tan x and cos square x there is no relation. There is a relation between tan x and the sec a square x. But you should to know 1 upon cos is what? It is sec x. So this is a hint for the second. In this way you can answer is what? 2 raised to tan x upon log 2 plus c. This is the final answer for the second question. Now the third one. Third I have given for the little bit difficult. It is evaluate integration of 1 upon root of 1 minus x square sin inverse x the whole square. But one thing is clear to you, I think. Whatever the sin inverse term is given, use that term for the substitution. So here we have taken sin inverse x is t. And rest of this time you know how to solve it. Now the mistake that you can make here. Here it is, you can make mistake over here. When we take t raised to 2 to the numerator, it will change its sign. Because we don't have the formula for 1 upon x raised to n. We have the formula for x raised to n. So definitely you have to take this denominator to the numerator. And when we take any term from denominator to the numerator, the power term change its sign. So this is a power and now it will be minus 2 because t raised to t square is in the denominator. And when we take that to the numerator, it will be t raised to minus 2. And apply the same. Xn plus 1. But here value of n is what? It is not plus 2. It is minus 2. So you have to make a little bit careful about here. Okay? When you take the term from denominator to numerator, change the sign of that power term. I hope that you will get it. Okay? What mistake you can make from these 3 examples. And you have to be very more careful in that. So answer for this is minus 1 upon sin inverse x plus c. Next topic is module integral calculus and topic is modulus of integration part 2. You have learned some important topics so far and we hope you had a good time learning with us. Browse through our online library for more content on the MSBTE website. Thank you. Stay connected. Happy learning.